Life started in water, and really all living things are in an aqueous solution. That means that a solution in which water is the base. And so we're going to be talking about this rule of like dissolves like. So everything that is in our body dissolves into water. Let me write this here for you. Like dissolves like. And this is going to be really important to living things because, as I mentioned, almost everything is dissolved into water. And so water is polar. So because water is polar, other polar molecules will dissolve into water. Not just other polar molecules, but also things with positive and negative charges. And so the example in this picture here is the one we started to talk about when we were talking about ionic bonds, sodium chloride. So remember, sodium chloride is made up of a positively charged sodium and a negatively charged chlorine. When a salt crystal lands in water, here's my water molecule. This is a polar molecule, so there's a negative charge here and a partial positive charge here. And because of these partial charges, these will interact with the sodium and the chloride. So what ends up happening, and so I'm going to move over here, here's my sodium ion. Water molecules will surround the sodium, and notice that the oxygen is surrounding the sodium because the oxygen has a partial negative charge. Chloride ions will also get surrounded by water, but it's the hydrogens of the water that will be near the chloride. And again, that's because there's a partial positive charge on the hydrogen. So ions will dissolve into water. This is why in our digestive systems, we don't really need anything to break down salt. We're going to have elaborate enzymes that break down everything else we eat. But as soon as you put salt into your mouth, as soon as you start chewing that food, it begins to dissolve into water and move into your digestive system, where again, these chloride and sodium ions will get surrounded by water. So you can see this from this image from your textbook. So just to define some terms, a solution, like an aqueous solution, is made up of two components: the solvent, which is typically the liquid, like water. Okay, so this would be water in most cases that we're talking about in biology. And then the solutes is whatever is dissolved into the solvent. So we were talking earlier about salt, so salt is the solute dissolved into water. So the ocean has salt dissolved into water. Solutes don't have to be solid. You could have gases. If you think about soda, soda actually has CO2, carbon dioxide gas, dissolved into it. And it starts to come out of solution or stop being dissolved as it fizzes out of your soda. An aqueous solution just means that the solvent is water. And so again, for biology, we're pretty much always dealing with aqueous solutions. As I mentioned a little bit earlier, like dissolves like. And so in water, ions and molecules that are polar will dissolve into water. Okay. If I'm dealing with oil, oil is nonpolar, and so you probably know that oil doesn't mix with water. So oil will dissolve other things that are also oily, so but not into water. So solutions are described usually in concentrations. So if we want to talk about a solution, we're going to say how much solute is dissolved in there. So let me get the pen here again. So a typical way to do this would be grams of solute versus liters of solution. So that's using the metric units. You know, just to give you a more everyday example, you might have a cup of sugar in a quart of Kool-Aid, for example. So you have the amount of your solute and then the total volume of your solution. It's also really common in science to use moles. So remember moles, that's that number of atoms. And so concentrations are often given as moles of solute over liters of solution. And that's just abbreviated as a big M, standing for molarity. So molarity is moles per liter. And so if you apply this a little bit and how we're going to see it in the labs, you might have a 1 molar solution of sugar or a 5 molar solution of sugar. And of course, this one is more concentrated, so you would expect that one to taste sweeter.